Okay, question 8, solve each equation. Um, I'm starting to get bored with these, aren't you? Let's look at part A. Hello, there we go. So, I guess not a lot of crazy things here. I'm going to use the distributive property, collect some like terms. Also, I guess I'll notice right off the bat that each side of this has a 7, huh? So I could subtract 7 from each side, so I don't even have to look at that. That's gone. And then if I use the distributive property, this will become 3 times 2x would be 6, and then plus 15. And then there's a minus 3x on this side over here. If I combine the 2x and the negative 4x, that's a negative 2x. Um, that's it on that side, negative 2x. Let's see. I guess I'll combine the 6 and the negative 3x over here. So that's 3x plus 15 equals negative 2x. I guess I'll subtract 3x from each side. When I do that, I get that 15 is equal to negative 5x. And if I divide by negative 5, I'm getting that x is negative 3. So I guess checking that would be perhaps a worthwhile endeavor. So if I bring my calculator in here, I believe I've got the left side all the way set up. So when I plug this in, I got 13 on the left-hand side, and you can see what I'm looking at here. It's 3 times 2 times and 3 times open parentheses 2 times negative 3 plus 5, and then I've got a minus 3 times. Can I edit that? Yeah, I can. I've got minus 3 times a negative 3 and then plus a 7. And when I evaluate that, that is the number 13. Over on the other side, I've got a 2 times a negative 3 and then plus 7 and then minus 4 times negative 3, and that also equals 13. So perfectly, the value x equals 3 does indeed make both the left hand and right hand side equal to each other, so this is a checked solution. Other problem here, B, not entirely necessary, but I think it handles it nicely. I'm going to use fraction busters. I'm going to choose to multiply both sides of this equation by 4 over 1. Why that? Well, I'm looking at my two denominators. I've got a 4 and a 2. And if I multiply both sides by 4, it'll handle both of those denominators, right? Clear out the fractions entirely. So if I distribute that through on both sides in the first case, and you know what, I'm gonna visualize this by, I'm literally placing a factor of 4 in that numerator, a factor of 4 here. I need a factor of 4 here, a factor of 4 here, and a factor of 4 here. So I'm pushing this factor of 4 all the way across all terms on both sides of the equation. So when I do that, this will become 4 times 1/4 x. This will just become x plus 4 times 5 is 20. That's nice. And then 4 divided by 2, because I'm going to bring a 4 over there. 4 divided by 2 is 2 times 3 is 6. And then plus, this will become an 8x. And then minus 4 times 14, or 4 times 4 negative. I am embarrassed to say that, yeah, I did use a calculator for that, but it is negative 56. So I'll take away an x from both sides. So I've got over here, this is going to equal 7x, and this is a 20. And if I combine 6 and negative 56, this should become just a negative 50. I can add 50 to both sides. That's clever and legit, right? So this is now 7x. So I think that x is the number 10, right? When I divide both sides by 7, x is 10. And I'm just going to run that through real quickly and check it here. So I've got 1/4, so 1 divided by 4 times 10. And that does put that 10 up in the numerator, plus a 5. Whoops. So I'm going to do that again. 1 divided by 4 times the number 10, and then plus the number 5. And I get 7.5 out of that. 1/4 of 10 plus 5 is 7.5. So on one side of this, I arrived at 7.5, and I'm going to check and see if it makes the other side 7.5 also. So on the other side, I've got 3 divided by 2. I'm going to add to that plus 2 times 10, and then I'm going to subtract from that the number 14, and I get 7.5 also. So because this value, right, x equals 10, made both the left and right hand side the same, it is absolutely the solution. So those are two answers for question 8. 8a was -3 and 8b was +10.